Hello everyone and welcome to our first video in our series for an introduction into Lewis structures of basic molecules and polyatomic ions. So today we're just going to be going into a basic introduction of how to do it for just very simple molecules just starting out. And if you'd like more advanced ones, please continue on to further parts of this series. So for this series, or for this video rather, let's just start off with a simple molecule. Carbon tetrachloride. CCl4. So the way that I like to go about drawing Lewis structures for these simple molecules is first starting out by counting the number of valence electrons in the molecule. Now for these basic molecules, most of them are going to be in the main group, so you can go about finding these valence electrons by just looking at the group number. So we know here carbon is in group 4. That means that it'll have four valence electrons. So we can go over here. I like to keep track of them. And chlorine has 7. So we'll put it down as 7, but of course it is tetrachloride, so we have to multiply that by 4. That'll get us 28 valence electrons. Then what you'll want to do is sum these together, and in total we have 32 valence electrons that we need to account for in carbon tetrachloride. And once I've done that, something you'll see here in Lewis structures is that we like to put electrons together as pairs. That's how electrons like to be arranged, and so it's good to just know how many pairs you need to account for, and once we get into drawing, you'll see why this is important. So just to count them into pairs, I just take the 32 valence electrons and I divide it by 2, and that gives me 17 electron pairs. And just an FYI, for most of these beginning molecules, we're only going to give you just even numbers of valence electrons, and once you progress, you'll see more radicals and lone pairs that you'll have to account for after that. But for now, we'll just stick to even numbers. Once you've done that, what I like to do is determine the central atom. You want to determine the central atom, and most of the time, this will be the least electronegative atom. And a trend you'll see with most molecules that have carbon in them is carbon will almost always be the central atom. And for these basic molecules, it will always be the central atom. Now here, the electronegativity of carbon, I know by memory, is 2.5, and chlorine, sorry, that doesn't show it up too well, is 3.0. So carbon is obviously the least electronegative one in the pair. So what we'll do is we know carbon will be in the center, carbon will be in the center, and then there will be CLs surrounding that carbon. And once you've determined what the central atom is, you'll want to draw out the central atom and make sure that it has 8 valence electrons around it, or 4 pairs. And this is something called the Octet Rule. The Octet Rule is one of the most essential rules you need to remember for Lewis structures. Basically, it's the idea that atoms tend to like to have 8 electrons or 4 pairs of electrons around them, and that just makes them happy in a more stable state. So that's something you'll want to achieve with all of your Lewis structures. So you want to start out with that, and remember it's the Octet Rule. This is a very common way of teaching Lewis structures, and I find it very, very efficient in doing so. So we know that we're going to have carbon in the middle. Now just some notation before we get started. We're going to assume that you guys know about bonds and covalent bonds. So bonds will be represented by a straight dash. So let's say we have atom A and atom B. This right here, this would be a covalent bond. In each covalent bond, there are 2 valence electrons. Now the other thing you'll need to know is if you have an atom with 2 electrons here, we call this a lone pair. And these are also 2 electrons. So now you can see why we like to make things in terms of pairs. So we know that carbon likes to fill out its octet rule. Let me just write out the molecule again. Anyway, so carbon likes to have its octet rule filled. So what we want to do is let's just draw a bond to each chlorine. Okay, so we know again that we have, 17 pairs of electrons to account for. 16. That was a silly mistake of mine. I divided 32 incorrectly. There we go. So we have 16 pairs we want to account for in carbon tetrachloride. Well, we have here 1, 2, 3, 4 bonds from carbon to chlorine. So that's 4 pairs that we can get rid of now we've accounted for. That takes us down to 12 pairs we need to account for. Now, we see carbon has obeyed its octet rule, meaning it has 8 valence electrons surrounding it. So now let's go on to chlorine. Well, let's look at, for example, this chlorine. Right now, it has 2 valence electrons around it because of its single bond to it. So let's get 6 more. We can put 1 lone pair, and that'll give us, you have 1 here, 2 electrons here, 2 electrons here. That takes us to 4, 5, 6, 7, 8. Okay, now this chlorine is happy because it has 8 valence electrons surrounding it within this covalent bond. So let's go on to the rest. This chlorine would also like 6 valence electrons to complete its octet rule. This chlorine would also like to do the same. This as well. And then once I'm done, something I'd like to do is just count up all my valence electron pairs and make sure that I've made up my my determined total that I did in step 3. So here we have, let me just count. We have 1 here. We have 1 here, 2, 3, 4. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And because we've hit this total of 16 pairs, we are all good. And this is the final structure, let me just draw it out again, of carbon tetrachloride. Now with Lewis structures, really the best way to learn them is practice, practice, practice. If you just go into Google, look up basic molecules and polyatomic ions, Lewis structures, just go to any website and you'll see a whole list of molecules that you can practice on. And of course, this is a very bare bones, stepwise method of doing it. And once you go through, you'll end up tweaking this into ways that makes it more efficient for you, and it's much easier for you to understand. This is just an intro, and there will be more parts to come. Please let us know in the comments if you have any questions, and please like and subscribe, and let us know what future videos you would like to see.